And now my slides, yeah, looks good. Okay, great. Okay, so we are in this time now when there's a huge amount of debate and interest and excitement and fear and concern around AI, and especially in the context of art. And we hear extreme things like AI is going to democratize creativity, or artists won't have to have skills anymore. Or on the other hand, we hear the doom AI will replace artists or kill art or make art terrible. And so it'd be nice to navigate this world with a more nuanced way. And I want to also begin this talk with a premise that AI is a technology that people use to make art. It is not itself creative. It is not the artist itself. It is a technology people use. And I gave a talk on this, explaining this, my view on this yesterday, and I also have a paper online you can read to hear more about this. But this is the assumption I'm starting with in this work. And so the question is, how do we think about the future of generative tools in given all this hype and energy around it, and it's, the future is pretty uncertain. And I think it's useful to look to the past to see how have previous technologies affected art and the way we make it. And particularly focusing on artistic technologies, that there's lots of study we can do about the history of science or science and new technologies in general, but I haven't seen a lot of this analysis in my reading for the ways that technology specifically influence art and the trends across them. And part of the reason to do this is to try to counter some of the cognitive biases a lot of us have about change. People often tend to assume that a new thing or a new style is automatically good or bad. Like I've heard so many times people say, how come no one makes good music anymore, like they did in the 60s or the 70s or the 50s or whatever their favorite era was. And so looking at history helps us get a broader sense rather than just the excitement or the terror of the current moment. And I particularly, among history of science, I really like this essay by a historian of science named Melvin Kranzberg, who wrote this piece called Kranzberg's Laws, which is a summary of his career in studying this. And he wrote, technology is neither good nor bad, nor is it neutral. And the point is that these biases often tell us, say all the new things are bad or the good, and there's a sort of techno-determinism one way or the other. And his point is that these things, new technologies can often have really positive impacts, have serious harms, be different in different contexts, different in short term and long term. And so it's worth taking apart these nuances rather than just assuming one thing or the other. So with that background, I want to kind of just, in the short time I have, review a set of trends that I see across many different artistic technologies from the past 150 years. So the first common theme is experimentation. When someone develops a new technology that can be used for art, the first thing they do is they start playing with it, see what it does. Here's the first known photograph made by somebody just playing in the equivalent of his garage with chemicals and optics and capturing light. And people just start in the early days of photography just playing around with it, just tinkering with it. Just they're both sort of artists and experimenters. You kind of have to be both. And there's this feedback loop from people playing with the technology, seeing, oh, it makes interesting pictures or it makes interesting things. Maybe I can change it or make it better. And then you fiddle with the technology, and then that gives you new artistic ideas. And there's a back and forth there. When we look at the early history of photography, there's all this stuff people were doing that was kind of like forgotten now. People were experimenting with panoramic photos and color and all these different ways. And now we sort of think of photography as handed to us, but it really came about as a result of people fiddling with it and playing with it and seeing what it could do. One of the outcomes of that was moving pictures, and people would just like film stuff, and it was just super exciting just to see the pictures move. We've seen similar things happen in the early days of, the early modern days of AI art, or sort of AI art since 2015 with Inceptionism and Deep Dream, which led to art exhibitions, and with Deep Dream and neural style transfer. And we have this continual process of people posting GitHub repos of CycleGAN and Pix2Pix, and then artists start to use that in ways that the original authors hadn't intended, and BigGAN and StyleGAN, and then a whole bunch of art came from people experimenting with those techniques. And so this iterative process moved online in the past decade, which was really fun to watch and interesting. And this is all, of course, before diffusion. Now, with the new technology, as it begins to approach maturity, new styles of new technologies for art mimic existing technologies before coming into their own. And this is something we pointed out by the new media historian Janet Murray. So early or classical painting in the 18th, 19th century often featured these sort of classical tableaus of a bunch of people kind of more or less arranged horizontally in a stage set, depicting classical themes or subjects. So the early photographers who wanted to justify their work as being valid art, who wanted to say photography is an art form, mimicked the styles of classical painting. They had, this is called pictorialism. They would arrange their subjects on a sort of stage set horizontally, and so on. And so, the painters who felt threatened by photography said, well, we have to do something different here. So we did atmospheric, impressionistic things that photography couldn't do, so they thought. And so the photographers mimicked that. The photographers basically imitated what was going on in painting at the time in order to justify photography as an art form. And it wasn't really until the beginning of the 20th century that photography really became into its own as a separate art form, and people started making pictures with photography that they hadn't been making with painting, at least within the artistic context of things that were shown in galleries and museums. Photography had its own visual language and visual content that was distinct from painting, and this took many years before this began to happen. Similarly, in film, movie making started with just let's put down the camera in front of our factory and film that, and this is just amazing and cool on its own. It's not really narrative. The first people who started to tell stories with film would set the camera down in front of a stage, and so they're basically filming plays. So it's basically theater but filmed. And so early filmmaking was really, they called it photoplays, even indicated they're really just filming a play. It's not a separate art form per se. You wouldn't think, why would you? It's not a strong argument for why film might be considered a separate art form. It was only within the next few decades that people started to develop the techniques of montage and editing, and moving cameras, things that are really specific to film as art form that you couldn't do on the stage in theater and plays. And then film was started to be seen as having an art form with its own language and techniques. And only by the 40s would we start to consider a mature art form. So this is a 40-year gap between the development of the technology to the first use for art, to the first use for having unique artistic techniques, to actually being viewed as mature art form. And probably a lot of people today couldn't even name a single movie from before the 1940s. There's a few pretty famous ones, but there's this whole period of experimentation which most people will not be aware of. Now, of course, in AI, obviously, so much of our AI techniques begin by mimicking existing styles as well. In all these historical periods, there's also a backlash of various kinds, and I'll mention a few. In some form, it's like this is not good art or this will kill art. So invention of photography, as soon as this was sort of publicly demonstrated, painters said, now painting is dead because here's a technique that automates what artists do and replaces artists. An early art critic described sound films when they added sound to movies as a sensation. It was hot, but it's just novelty. How long can this appeal last? And I'll just say it's just because I'm going to come back to this. Before sound, you would have a silent film where there'd be live musicians playing music in the theater, and then they started, with the jazz singer, they could record the soundtrack that would go with the movie. And years later, the same critic, Arnheim, wrote that in the movies got worse when sound was invented because it was a novelty and people were using it like a gimmick, and because they didn't really know how to use it as an art form. It took a long time to figure out how do you incorporate sound into movies in a way that worked. And of course, and this you can just keep when you start looking through the archives, there's just endless lists of people saying, here's the president of Paramount saying that sound film will never replace silent film. We're always going to have silent film, and we look back, decades later, that it just seems ridiculous. Another favorite example of the film critic Roger Ebert saying video games can never be art about 15 years ago. So when people say, I've never seen AI art that has the same soul, it touches me the same way as my favorite works by Rembrandt, then I feel like that's just a ridiculous standard to hold a new medium to. Of course, when you start out with a new medium, it is about experimentation and trying something new and seeing what happens and seeing if it's any good or not. It's ridiculous to expect all of our art experiences to be at the very absolute best standard of all time. There are, important impacts on how employment and skills required to make art change. In the early days of photography, it really replaced portrait painting and art. Here's one artist saying basically that photography removed a lot of jobs for artists, for real artists who would have made their income off of portrait painting, and many had to switch to photography, portraiture instead. Film has many, many of these different transitions over time, from cinematography requiring huge, bulky, expensive film cameras and director of photography and lenses and pullers and stuff, to by the 80s, an indie filmmaker on his own could carry his own camera and be his own cinematographer and director at the same time. And now, anyone with a smartphone can make a movie, and so many people, creators are making their TikTok and YouTube videos and getting, a lot of recognition and monetization or money from basically being a one-person film crew. Editing is a similar situation. You used to have to cut out pieces of film or audio snippets and tape them together. And editing was a long, slow, laborious process. In the 80s, it became digital, and now, again, anyone with a smartphone or a laptop can do their own digital video editing. But this doesn't mean that everything is on the low end. There's this huge explosion of high-end film experiences in TV, streaming video that has very high production values. And you look at the credits of like so many different movies and TV shows, and then just the number of VFX artists and computer graphics animators and effects artists and so on is just endless, it seems like. These technologies have often played roles in power struggles as well. So when sound film was invented, it did mean a threat to the jobs of the performance musicians who would perform music together with the movies. And they campaigned against this, and they argued that hearing music from a recording was not really music as compared to music being played live. And performance musicians did lose jobs as a result. Streaming is one where we're really, we can kind of look back at the past and say, haha, like, oh, a few things, a few people lost their jobs, but like, we're living in a time now when lots of people are really being hurt by these transitional technologies. Streaming is one where, like, I cannot imagine going back to a world of buying CDs or VHS tapes or DVDs or anything, and yet the new streaming platforms like Spotify and Netflix have enabled them to dictate the terms of how artists get paid in ways that have been quite harmful. And this is, the writers' strike from last year is a response to this. And if you're interested in this topic, I recommend the Choke Point to Capitalism by Rebecca Giblin and Corey Doctorow. And what they really point to is that in so many of these media fields, there's a monopoly around the ways that artists get paid. And so, and that really, the technologies then work in favor of the companies there. So in all of these technologies, I think in some ways, sometimes small and sometimes large ways, they transform the way we think about art. And this is a very, very short talk, and so everything I'm saying here is super compressed. But if we look at painting, painting went from being realistic to being atmospheric to being not very realistic to being completely conceptual. And I would argue that photography was the reason, or one of the main reasons, for modern art. It completely transformed the way we think about modern and contemporary art. Recorded music was one of the things that made hip hop possible. So with two turntables and a microphone, two people could be an entire band, and they could form music by using samples from other recorded music. And this was a new kind of music that worked from this recorded music that had been so threatening before, which is itself led to different ways of thinking about art and creativity in terms of remix and reuse of existing ideas and recombination of them. And I really like this web series that makes this case more thoroughly. Now, I've showed you all these successful examples, and there's a little selection bias here of all the things that worked out. But just because something new doesn't mean it's good or will be successful. There's so many things throughout the years, like smell-o-vision in the 50s, and 3D cinema has had its ups and downs. NFT and smart contracts have been viewed as an art platform or art, separate art medium in smart contracts, and I would debate whether these are really positive or not. I think they have a lot of harmful aspects. So how does AI fit into all this? Well, I do think that we have to think about AI as a technology. So It has all these attributes of other technologies. It can be good or bad. It can be useful artistically or not very interesting. One thing that feels different right now from a lot of these examples is the rapid pace of change that, film had that like 40-year period from, before becoming mature. And now it just feels like, or, let's say even 40-year period in photography from like invention to people being able to use it, maybe even more. And now it feels like these new tools are moving so fast. And that might be an illusion. I'm not sure. And of course, the use of scraped data in a lot of current techniques is a hot topic as well, which is a whole other can of worms. So I think, just to sort of finish up, I think a common theme here is that as the tools get better, the bar for what we expect for art gets raised. Like we don't say, okay, well, now we perfected 19th century art. We're done making new art and we just have the machines do it. We expect more and more out of art and about how people communicate. When things are too easy, we recognize that a person didn't work very hard on it. So that means that good art will always be hard to make, and we're always going to want artists and care about artists create and how they communicate with all of us. Like I said, this is a very lightning fast speed through a whole bunch of topics. If you're interested in diving further, this talk is based on a bunch of writings I have online, especially this When Machines Change Art essay on my blog. Thank you. Okay.
We do have time for something, so feel free to ask if you have any.
The big issue with the AI art seems to be the last point that you mentioned, the scraping of the previous art, which is very different from the way the other technologies are kind of better example. Would you like to elaborate on that last bit of it?
Yeah. Yes. Yeah. So the question is, the issue of scraping is very different from past art changes, and can I elaborate on that? And I think so. It's not so. So I guess there's a whole bunch of points to make. Like I don't have a strong position on this, but a few observations. One is that it's not completely new that like this everything is a remix claim makes the point that all of our art is remixing and reusing previous ideas. And the whole long story, Shakespeare is reusing classical tales from hip hop, explicitly sampling. I think I think a lot of times the scraping issue gets so one observation I didn't have time to talk about here is I think that in terms of the backlash and the debate, people's personal interests become part of their like the aesthetic judgments stand in for the personal statement. So when someone says AI is awesome, it's going to democratize creativity, they're often someone who has been a game from that, from like a startup company or something. When people say this is bad art because it's stealing from other people and it's scraped off the web, that's often because they feel threatened that it affects their livelihood, which is a quite reasonable fear to have. I think that remix and reuse is a completely natural form of art. Direct copying, I think, is not okay, and I think we have existing copyright laws which are designed to protect against that. And I guess there's so much more to say, but those are a few observations.
Any other questions?
So I've talked to some artist friends that they said that so in the current stage it might still be a little bit difficult for them to communicate with the AI tools. So I just want to hear your opinion that besides the current ways like text to image or image to image, so what do you think will be a good way for the artists to use the AI tools to communicate with those AI tools?
The question is, what are good ways for artists to communicate or use AI tools? I don't feel like I have a strong opinion about that. I think that I definitely think that the current tools are not good. Like text to image is a terrible interface for fine-grained artistic creativity. You need to have things where you can control it. And I guess I'm sure we'll hear lots more today from other people who have more nuanced opinions about this. I guess my main comment is that it's an iterative process. We don't just say, okay, here's what the art in 10 years is going to look like. It comes about through people working, developing tools, working with artists, getting feedback, or themselves doing both roles. And you have to discover these things through a process, not by trying to predict the future.
We do have time for one more question. Any present questions in your mind? I can ask one. So, yeah, so I was thinking, like, I think during the talk, I mean, you show the evolution of how technology basically evolves into art at some point, or like helps evolve new art at some point. I wonder, like, if this technology is aiding creativity or art development in somehow. So what's the difference of like aiding creativity versus actually being creative? So, yeah.
So the question is, what's the difference between aiding creativity and the tool of being creative? And I guess I'm very skeptical of the idea of any tools being creative. I think they can play, they can play roles in the creative process. Let me just give an anecdote. Or maybe a few anecdotes. And this is maybe not be an answer, but anecdotes. So much of my experience with creativity, personally, in both research and in painting, is like I start with an idea, I do a thing, and then it turns out to be very different than my original thought, but the new thing is more interesting. And so much about, for me, creativity is discovering along the way what problem I'm solving or what the goal is, and then exploring that. And things where you knew in advance what you were doing maybe are not going to be that creative or not that interesting. And I don't really think we have a sort of a computational way to think about that. Maybe it's possible, I don't know. And I guess the other thing is when I first started using Dolly 2 years ago, like I would type in a prompt and I would get out a thing like, oh, it's not really what I was expecting. That was interesting. And that suggested another idea. So I tried a different prompt. And it ended up like going on this long path that was very different. I ended up doing things that I never thought about when I started out. And so that the tool had suggested things that led to more ideas. So it certainly participated in the creative process and provided some model of like, it's providing all the technical skill of making the images. And I'm thinking of new prompts based on what it did. And I feel like there's something about that where it is participating in creativity in a interesting way, but I don't know how to label that necessarily.
Thank you so much. Next time, Aaron.
Okay, let's welcome our next speaker, Jiabing Huang. So Jiabing earned his PhD from UIUC. He currently holds the position of Capital One Endowed Associate Professor in the Department of Computer Science at the University of Maryland, College Park. He's also 20% affiliated with the Meta Reality Lab. He has been focusing on 3D vision, generative models, and graphics. Now let's welcome Jiabing.
Oh, let's see. I need to swap. Okay.
Yeah, you can also mute yourself. Yes. Okay, great.
Oh, okay. Yeah. Hello. All right. But this shows up like this.
Swap, please.
Let's see.
I think it's like sharing screen, which screen to share.
Screen. Steps 1. Yep.
Now it's good.
But I
But
think that's
Oh, understood.
just to share the different things.
Can you go to the PowerPoint?
Point.
And then go to this slideshow
Slideshow.
and then custom show.
Custom show.
Yes. Okay. No, just close it. Maybe you can you actually just
Sure.
yeah, and then try to get any feedback here.
Swap. Where's the swap? Let me.
We can see it here, but
I think there's a swap display things. I think I saw earlier on the Zoom. It's also the different swap displays here. Okay. But I guess Zoom will probably see different.
okay. I think it doesn't matter that much.
All right. Oh, maybe I can share Zoom this.
Share Zoom.
It's screen two. Yeah, that's awesome.
Oh, okay, awesome. All right, thank you for you inviting me. So I'm going to talk about how we can kind of create our visual imagination in a controllable way. So this is common knowledge that human, as long as we can remember, it's creating visual arts or create visual images to convey, to share experience and create kind of their own expressions. And these kind of habits create when we have more better and better tools, we start to see more and more kind of complicated creations from the art. And since the invention of the camera, it's been never been easier to create kind of capture reality from just a snap of photo. And nowadays, everyone has a phone in their pocket, and so this is a photo I took of my two kids playing around the ball pool. So it's kind of capturing all these kind of memorable moments of our lives. It's never been easier. And everyone knows that around 2022, so there's an explosion of generative AI art that kind of democratize all the kind of everyone's capability of creating stunning visual images. And of course, nowadays you see that all these kind of major players all have their own tool of text to image generations, like all these examples. All right, so but does that mean that art is dead? Like everyone can generate really stunning images. But I really like this quote of from American painter Robert. So what he says is that art is not really just an object that you created. It's really the experience that the artist kind of intended, created, crafted, so that you can connect with your audience. So I like. Is it on? Okay, all right. So I like to think about like we as a human creator, when we have some ideas that want to convey, what should we do? Like so now we have a remarkable tools for us to do that. For example, we have some kind of generative models that can generate like art or visual images that we want to convey. We want to share our visual experience. And this could come from a variety of different forms, for example, images and 3D models, or kind of you want to create a scene, you want to create a immersive experience. But we usually kind of this diagram only shows a human creator and has the idea, but and then everything is kind of black box to the model. But what I like to think about a better strategy is to have a human, like you can think about you are like a DJ, and then you have some control panel that can really focus on how you can convey your intention, how you can create your visual imagination. So in this time, I'm talking about some of the examples of how we can better design a better interface with kind of this machine learning model, leverage the power of generative models so that you can create something that's better aligned with intention. Okay. All right. So let's talk about images first. So everyone knows like you have all this great text to image generations. So when I look at that, I found that it's really weird that in everyday life we communicate not in plain text. We communicate with each other in emails, in newsletter, everything is in rich text, right? So we all write in rich text, but somehow the text generation models just use the plain text. And I want to use this example to highlight that there's a huge difference between the meaning of this two exactly the same word, but completely different meaning, right? I will always find you. So we try to kind of explore a little bit, for example, design interface that how you can interface with the generation model. So here we if you just like a long hair, if you just mark that as a specific color, and you can change the color and the hair color will change correspondingly. All right, so it's a much intuitive interface for you to kind of, in your text itself, it's kind of fully specify what your intention is. So there are several different interface for rich text. For example, you have font styles. If you just change the font style that describes the specific artistic style, you can create like some of the wave is a particular style, and the kind of the sky is a different style, and you can mix and match, and it's become very easy to use. And I like this kind of, usually you don't get to the final in art in one step. So usually it's an iterative process. So what we come up with this is a full node idea. So basically you have a full node is basically try to describe some of the particular regions, and I want to describe this in detail, right? So what we can do is that you can start with kind of empty thing, and you want to kind of, okay, what the coffee table looks like. You want to have some candle and greenish things, and you want to kind of decorate the room iteratively. So through this iteration process, it will gradually help you to convey your intention better. Right, some other things, for example, you can have a hyperlink. So specifically, if I have this dog, but I don't care about this dog, I care about my dog. I want to create these things with my dog inside. So I can create a reference image to do that. Okay, you can create a font size. I don't know whether there's Italian here, but they will be pissed off if we increase the pineapple here. So you can actually do this. All right, so you can kind of adapt the change the font size, emphasize particular element in single element in the thing. All right, so how do we do this? So just a high-level overview. So you have the kind of text to image generation model. Usually they are kind of diffusion based. So iteratively remove the noise from the thing from the things. All right, so you repeat multiple times. You get all this, and throughout the process, you'll get something that's called the feature maps. And you'll get also the self-attention and cross-attention maps along all this process. So what we do is that we're going to see what cross-attention maps, but basically it's the attention between the text tokens and the image features. If you look at all these kind of attention maps, what you'll find is that if you average them, you'll find that they are arranged in the number of pixels in the columns, and the rows is the number of tokens. Right. So imagine that if you can take the one of the tokens, and then you can visualize it and reshape that into a 2D image space, what you'll find is that they correspond to different regions. That this is how this text token is being injected onto the images. Okay. All right, time's up. Oh, all right, that's quick. All right. Yeah, but the problem is that it's not really precise. So it's hard to use this directly to create visual images. So what we did is that I use kind of self-attention maps that we found that if you cluster in this self-attention map space, if you run the spectral clustering, it gives you kind of region-based, very precise region-based control, and use this to align the cross-attention map. That helps you to create a very precise, we call it token map. Okay. So once you have these token maps, what you can do is that when you have a rich text editor, you change that into kind of like a JSON file, and that describe kind of have a region-based control. And then, but you want to have a very coherent result, right? You don't want to just generate things independently and pass them together. So what you do is that you create all this kind of JSON file, and then you can run independent diffusion process. And at the same time, in every step, you try to kind of merge all this merge region-based control into this process. Okay, and that's how you can generate these things. And for a more precise control, we also add some of the, for example, if you want a specific color, like for example, if you're some brand, you want a specific color, how you can do that? You can use this and then computer gradients on this color, and use gradient control to control the process. And that way you, okay, all right. So that way you can allows you to kind of really get what you want very precisely. Okay, so yeah. So this is some example. So if you write this in a rich text, and of course at that time it's still slow, so we skip the compute here. But now you can have a lot of distill model. You can run very fast. So you can write for example the color, and you want to kind of describe a little bit about what the style of the white flower looks like, and so on. And if you want to have like a crystal clear, like bluish lake, you can have very detailed description, and that when you change that, you won't change other aspects. All right, so this is a kind of rich text. I think It's very intuitive, and then but it's a little bit and I hope that this will be picked up by some of the this like text to image generation models, and I think it's very interesting aspects. All right, so this is about composition. This is about image editing. Like, suppose I have some other editing. Like, suppose if I want to have an input image, I want to ask, say, I want to kind of raise the elephant head. But what the current state-of-the-art methods will do is that you would just generate, turn the elephant head from the turn the giraffe head into an elephant head. Like this kind of bizarre generations. But what can we do is that if you want to have a specific concept I want to create, for example, I want to raise the elements, the lion head. So what we can do is that we can just like make a course edit. Like, of course, I'm really bad at making this real. So we can just create a very coarse edit, but we can now use the diffusion models to kind of fix up these errors. So it's become, so text itself is not really a good interface for making these designs. For example, here's another example where we want this horse to fly. Like, this is a kind of coarse edit we have. It's very bad visually, but if you can use this, and it can have much better visual results. Okay, and this is very precise because in this case, my intention is about spatially. So I can use this to generate this. And compared to the existing method, the existing method will have difficulty in handling these cases. And what's more interesting is that it's also, if I want to insert I just want to insert one thing, you can see that all the reflections are also created along the way. So the whole thing are harmonized. Again, compared to existing method, they won't have this kind of, they'll have the limitation in handling these cases. So here's the interface that we can generate. So if you want to just, I don't want this composition, I want this particular composition, you can generate this very precisely. And they also kind of, we train on natural images and natural videos, but it also generalized quite well for non images out of domain. For example, in this case, you can actually kind of move the arms, and then you can generate these images. And this Y here is, he looks a little bit not that confident, so we can raise his eyes and then kind of open his arm, and now it looks a lot more confident. Okay. All right, so this is kind of another way to kind of interface with you yourself with the generative models. Okay. So this is images. So how about objects? So a lot of time we want to, you have 3D object. If you are an artist or you're a designer, you want to have 3D object assets, like say this couch here. But I want to kind of design interesting texture patterns inside. And I have some inspiration about the images that we saw. For example, this chair, I really like this kind of this chair. Again, if you use text to image generation model, let's say if I kind of first use the captions, describe these things, but if you just use this to kind of texturalize, create a 3D texture of your thing, of your 3D object, this is the result you get. But this is very far from what your intention is, right? So what we can do is that instead we can create a much better result by using a reference space. Like, you have an image that is a reference, and you can use this to guide the texture generation. You can basically transfer the texture from 2D images onto 3D assets, right? So you can do this for a variety of different applications. For example, you capture a bunch of them. You have some designs in your daily life. You can capture these images and then transfer those designs onto your desired text assets. I like this one particularly. It's fun, and you can create all this kind of visual assets by just using images. And it's cool because it's very precise. It aligns with the intention very well. So, for example, you can design a new toy. For example, take your existing toy, you can create new variations. Right, and then or you have a cup, and you can create a variety of different. Like, I like this cup. I can create an artistic design of all my furniture aligned with this cup. Okay, or like generate all this kind of fluffy, make your room a little bit fluffy. And all these things are kind of relatable, so you can actually relate these 3D assets in a different environment. All right, so I'll quickly go over kind of what the main idea, how this works. So basically, we try to train a BIDF neuron field for every point on the surface. Want to predict the albedo, roughness, and metallic. So basically, this will help you kind of capture a variety of different visual appearance. But how do we train this? So what we do is that you can take the render camera view. So this is pretty much standard. Like you render camera view, and then you have a noise doing full diffusion process, and then you move that into a diffusion model that will give you a noise. And this process is known as the you can propagate the gradients here. The process is known as the score distillation sampling. So it's pretty much very popular techniques in 3D generation literature. But the problem is that if you just use text, it's not precise enough. So you cannot generate really good results. So this is the result you get. It's not really what I want. So what I can do is that you can, so what we did is that you throw away this model. You can create use a dream boost fine tuning. You create a generative models that specific overfit to these examples, and then create this kind of fine tune model. And once you have this fine tune model, you plug it back, you'll get better results here. Okay, so it's slightly better, but it's still not precise, right? It still have all these artifacts. And you can use advanced methods like a variational score distillation. Okay. Right, so you get slightly better results, but the problem is that you still have all these artifacts. This is because the image generation, that the denoising process, it doesn't know that this is a 3D object. It's only known this as 2D images. So what you can do is that you add some control signal to provide some geometric information into the process. So you can render surface normal and then use this to control. So by integrating all these basic techniques, you can generate a pretty very high quality 3D textures. All right, so, and once you have this, you can distill that into a standard 3D assets. All right, so let's talk about a little bit about scene. Okay, so one of the thing is that you can nowadays you all can generate like very high quality results, or this is a result from Sora. But what one step we did is that you can, from these videos, you can create a 3D video that allows you to navigate the scene. So essentially, you generate not just an object like a video, but also kind of a representation that allows you to kind of move around the scenes. Okay, so here's an example where you kind of Sora video, but you can create interactive experience from these videos. Okay. All right. So another thing I think is very interesting is that once you create say you have a like a 3D model or kind of capture images, you create a radiance field that you can walk around. But one thing interesting is that how can we kind of simulate effect in these things? For example, one of the projects we want to simulate is that simulate what the climate change will do to our environment. For example, we can simulate what a flooding scene will look like in this playground, and you can simulate all this kind of city. Your city, if your city gets flooded, is kind of very likely true in the foreseeable future. Okay, so you can simulate the kind of scenes. Again, this is align how you can, if you have some artistic expression you want to kind of convey, you can simulate this through this kind of technology. And as you can see that all the ripple and refract is all these physical base. So they are kind of, they're very precise. So of course, you don't need to be just the flooding, but you can also kind of have some snows. For example, some areas shouldn't have snow, but because of the climate change, you change the kind of what climate pattern. You can have like the smog as well. For example, you have all this kind of wildfire. Right. So again, this is the kind of, we want to create a precise control. For example, all these are physical based, so you can control these kind of models very precisely. All right. So to conclude, I talk about a variety of different ways of how you can interface with those kind of powerful tool of generating models or physics-based rendering, and how we can generate different variety of different medium, and that convey your visual imagination. I want to highlight all the students that behind all this work. They are the main driver of all this that would make this possible. And I was thank you for your attention, and I'll be happy to take any questions. Oh, all right. So I used up all the time.
No, I think that's time for questions.
All right. Yes.
Yeah, so is there any way to physical condition, for example, for a heater for water, from water to the heat up to vaporize, and you visualize this based on the physical condition, based on the theoretical physics. Yeah.
Right.
The rule, basically.
Yeah. So I think you can do that in purely computer graphics way, but I think nowadays, like all this video generation model, this is exactly one of their limitation. They don't know how the world works. So you see some of the failure cases, for example, from various different video generation models. You see that the object is not supposed to be rigid, but still deform in bizarre way. So all these are kind of quite hard to model. Yeah, but this is very exciting directions. Yeah. Yeah. The itself, like at that time, like generating an image, it takes around 30 seconds. We use stable diffusion XL. And adding that, it probably just add like a 10% of the latency. The main computation comes from that you run this process once, and then you add all this attention maps, and you create these token maps. And once you have the token map, generation is very fast.
Any final questions from the audience? Not, let's
Awesome.
again.
Thank you.
Content creation in general. And I'm really excited about like introducing Anastasis and learn more about what Runway ML is doing. Hopefully, if we're lucky, we may hear something about Gen3. I don't know if you will talk about it, but probably some of you have seen in Twitter and social media about Gen3. So let's welcome Anastasis to the stage.
Hi, everyone. Thank you for having me here. I'm going to be discussing, this talk is going to be in two parts. I'm going to spend the first part talking about our latest model, Gen 3 Alpha. And then the second part is going to be about kind of more of a high-level perspective of like what this model represents and like where we headed at Runway, kind of how we're thinking about those models beyond video generation to something broader. First, I want to give kind of a very like a 1 minute kind of overview of what has happened the past 5 years, what we've been working on. The progress in video generation has sped up quite a bit. When we started, there was barely any video generation models. It was more taking an image generation model and then doing some interpolation tricks to generate video. And now we're at this stage where we can produce fairly coherent, high quality photorealistic video generation. Of course, there's a lot of room to further improve things. I think we're still very early in terms of like where those models can go. But it's quite remarkable, like what has happened in just a few years.
Sorry, can you be closer to the microphone? Or you can do it as well.
I'm going to talk about Gen 3 Alpha. So Gen 3 Alpha is a model that we actually just announced yesterday. It's a text-to-video diffusion model that's capable of generating high-resolution outputs up to 30 seconds long at the moment. And there were a few aspects that we paid a lot of attention to as we were building Gen 3 Alpha. The first one is just improving the fidelity of video generation. If you use Gen 2, which was our previous text-to-video model, you know that there are a lot of issues around geometric consistency, just the ability of being able to maintain the same identity over the course of the video. And those issues we really paid attention to and tried to improve. A lot of those improvements came with just a much greater scale of compute and data that were used in training this model. But there were some design considerations as well in terms of how we're thinking specifically on the captioning side, on the architecture side, in order to kind of get to this level. Given that at Runway we come from kind of this hybrid art and science background, aesthetics were also really something we thought about from the beginning and figuring out like how are we able to build a model that's quite versatile and go beyond a very common aesthetic that a lot of generative models have. And so I think we made quite a bit of progress there, but of course there's a lot more room to go. So I'm going to talk a bit about this kind of the dense captioning aspect of how we train Gen 3 Alpha. So one of the main limitations with a lot of captioning methods, even video, is this kind of idea of content bias, of just really describing the visual contents of the scene, but not actually paying any attention to what's changing through the scene. And that ends up having a downstream effect of really limiting the amount of control you can have in terms of like what kind of transitions or actions you can describe in a scene. And so with Gen 3 Alpha, we used both highly descriptive captions, which has been kind of very, very common approach in latest models but not just a single caption, but actually multiple captions for video. And this allows describing like fairly kind of unexpected and interesting kind of transitions. So this is one example of a transition that, you know, it's quite out of distribution, just you entering a abandoned mansion and inside there is a laboratory. And previous video generation models would usually tend to handle those transitions by just introducing a scene cut. But we were able to fairly consistently produce this kind of smooth interpolated results. This is another example of like the kinds of kind of capabilities that we see with dense captions. So again, this is a fairly like you can describe like fairly drastic change in the scene from the beginning to end, and the model is able to handle them kind of reasonably well. again, another example where you're starting with just an empty warehouse, and then you can describe this this change in the same in the same manner. As I mentioned, we paid a lot of attention to aesthetics. I think it's an aspect that's kind of very often becomes like a consideration further, like late in the pre-training or in the post-training process. And for us, it was really important that this model was made kind of in collaboration with the artists that were on the team, and like that kind of their input was really really drove some of the kind of decisions we made around essentially kind of how the data mix that we use and kind of how we kind of thought about kind of captioning and metadata. Kind of more on the alignment side of things, the model is quite capable at rendering text. You can one kind of nice thing compared to kind of highly capable text render like image models is that you can have that text transition in all kinds of ways, and also be kind of be positioned in the scene in a kind of in a 3D way. So this allows for some kind of very interesting kind of reveals, kind of interactively, kind of physical interactions like this one. And something that we also found is that this model has some rudimentary, I would say, understanding of physics that's much kind of better than what we saw with kind of the previous generation of models. So it's able to kind of recognize like what happens when fire kind of meets rain. It's able to correctly fill a cup with coffee, and like have the what we often saw was that like different elements of the scene in previous models would just not be synchronized. So you have the coffee cup fill up on its own, and kind of regardless of the coffee that's being poured into it. And I think this is really exciting, and it kind of points to this kind of emergent understanding that those models build around like different interactions in the real world, both in terms of human motion, but also in terms of like physical interaction, different elements. Everything is kind of learned from scale. There's no kind of explicit kind of priors and knowledge that's been fed into those models, yet they're able to kind of quite convincingly in some cases be able to kind of simulate that phenomena. And I think as those models further scale, we're going to see, I don't see a reason why that those capabilities are not going to become even better. This brings me to like a line of thinking that kind of we've been very focused on a runway for say the past year. I think as those video generation models improve, I think it's like one framework of seeing those models is they're kind of trained to predict kind of their data, and another framework kind of comes from this. I think this paper actually kind of encapsulates quite well, and it's this idea that as you increase the scale of compute and data, you're seeing these convergent representations arising in models of different that are trained on different modalities. So the part of the reason for that is that like any kind of modality, any kind of data is actually a reflection of the real world in some way, and so as you're kind of accumulating those different reflections of the world, it's natural. And then the other reason is as you increase scale, models are able to kind of come up with like more simple explanations of ways of predicting the data. And so this is this idea is kind of called the Platonic representation hypothesis, and it's essentially kind of this convergence notion that models that might be trained on completely different modalities, where there's no overlap of training data, end up kind of developing representations that are very similar to each other. And so if you're seeing those different kind of training data and different modalities as just reflections of reality and just maybe emphasizing different aspects of it, maybe text has like a more kind of perceptual bias versus video, then you start to kind of think of those models as not necessarily as just predicting the modality that they're trained with, but also developing this more kind of modality agnostic understanding of the world. And I think that's a really exciting, really exciting direction that we're very much, I think, at the early stages of discovering. And just to kind of give an intuitive kind of framework for this, like this is how I've been thinking about training those large models is, like when the model is being trained, kind of depending on what it is in the training data, on like what things it's most important for the optimization to predict. It kind of gains this kind of knowledge and repository of kind of facts and subroutines that it uses to make predictions. And more capable models develop kind of higher order subroutines than less capable models. So an example of a fact would be, an apple is red. An example of subroutine would be maybe in the context of kind of generative visual models that applying a specific style to the output. And as those models increase in capacity, as we increasing kind of data that they're trained with, they might develop more kind of higher order understanding of things. So instead of learning a very specific style, they identify patterns in like a kind of a set of styles, and they're able to kind of derive and they're able to kind of apply the style with this more higher order kind of subroutine. So that also, as small increasing scale, kind of raises also the question of kind of interpolation versus extrapolation, and just like the models are able to quite convincingly kind of extrapolate to new tasks because they have this very general kind of representations and subroutines that they've developed. And yeah, again, kind of going back to the Platonic representation hypothesis, I think like as those models increase in scale, they learn elements about the world and elements and knowledge about different kind of concepts, different aspects of reality and kind of human society, in a way that's modality agnostic, and I think that that makes kind of video generation kind of a more broadly interesting, potentially kind of a task to solve. And controllability for us at Runway is a very important piece of everything that we build. Making those models interactive is kind of and usable. It's really the key to actually getting kind of artists that use the platform to effectively kind of make interesting work with those models, and also feel like that their work reflects their vision. And one way to think of controllability within that framework is that like those models have already learned a lot of different things. They've learned, for vision generation about 3D understanding. They learn about they learn about text. They learn about different animals. They learn about all kinds of aspects of the world. And controllability efforts are not necessarily always injecting information, but rather making the subroutines of the model more legible to the people that use that model. And controllability is how you get from, I think one way to think of controllability is how you get out of the distribution. Like building those models is really an effort of modeling the distribution of the training data. But in order to actually produce kind of things that are artistically interesting, like interesting kind of juxtapositions or kind of combinations of concepts that haven't thought of before, you need to provide those controls in order to actually get kind of out of that distribution. And I think this is a way for me to kind of conceptualize this intersection of art and science as why, like, where do those two meet is that, like we need to build more capable models. We need to create models that understand the world better, because they gain this like more intricate rule set about how the world works. And so when you build tools around those models, then you're able to steer them in much more kind of spectacular and interesting ways than before. So this is an example of a kind of controllability effort that we released last year. It's based on the previous generation, our Gen 2 model. It's a previous text-to-video model. It allows providing precise control over the motion of certain elements on the scene, and also the ability to steer, kind of to provide camera control. So you're essentially determining the trajectory of the camera in the scene. And the way I'm thinking about this is that as the models increase capability, the actual granularity of control will change as well. So you have like more kind of traditional creative tools provide control over pixels, low-level control over directly the modality and the representation that you're using to kind of store this data. Those kind of newer kind of generative models that have kind of emerged over the past few years provide control over concepts. So you can mix concepts together that were not not necessarily in the training data. And as those models become even more capable, you have this ability to potentially kind of provide controls over walls. So as those with models like Gen 3 and the next generation of video models, as they build a more consistent and powerful representations of the rules of the world, you're now able to kind of interactively build new worlds and control things on a much higher level than before. And this is the direction that I think is it's a really interesting kind of exploration that's just becoming possible at the current scale of models that we're seeing. That's it.
I think we will have time for one or two questions. So, any pressing questions or in your mind?
Yeah, so one of the kind of statements that you made is intriguing. Can you elaborate on that? The art is out of distribution and training is distribution. What do you mean by out of distribution?
Yeah, so if we take the example of the motion control and camera control feature that we had, you can provide a camera trajectory that's not necessarily has ever been on the training data. And because the model has built this understanding of like how to kind of how camera might move in the scene, by conditioning the model in its camera trajectory, you might be able to create any like a new kind of cinematic style that was not necessarily present in the training data. And this applies to kind of other things as well. So like if you kind of more on the concepts side of things, like you might kind of train a model with a lot of examples of a person playing guitar, a lot of examples of pandas, and you can kind of prompt the model to a panda playing guitar, and it's able to kind of, because it's built this kind of separated representations of all those things, it's able to combine at test time those two concepts and create something that's not necessarily in training distribution.
The more capable models seem to be learning physics for free, the way that large language models learn grammar for free, just by seeing a lot of patterns. Have you considered trying to explicitly teach the model some basic rules of physics?
I think it's generally difficult to introduce those kind of inductive priors into the model without like limiting it in some other way that you didn't anticipate. It's just been I think the lesson of the past few years that those like the models are able to learn now with scale. Of course, at the control building post-training phase, you can inject kind of more precise control over physics, or even have like another model that's conditioning this model that kind of provides that control. But I think having the models be as kind of not hindered too much by those inductive priors has allowed them to learn things that you didn't necessarily expect, and we found that predictably geometric consistency improves with scale.
So in the Twitter, it said your infra empowers your model to make it happen. So what is exciting infra improvement for support of this kind of new model?
Sorry, I didn't catch the question.
There on Twitter, there is a new infrastructure. So what most exciting part of the infrastructure you think about, like make this happen?
Yeah, so there's a few different things. I think, well, one is training video models is hard. It's much more difficult than training language models because kind of especially high resolution video data could be quite difficult to kind of figure out from the loading perspective and so forth. So a lot of it is just, building, making sure we can respond to these challenges to build models that can work on high resolution video data. I think the captioning pipeline was also a really interesting component of this. Kind of we can potentially caption a large corpus of data. And then the other part, which we're releasing Gen 3 alpha to everyone in the coming days, and we really want to make sure that it's as fast as Gen 2 and don't kind of compromise on the interactivity. And it turned out to be it's actually faster because of the optimization made. So like for us, interactivity is really important, and I see in kind of near future where those models become closer to real time, and that's a big focus for us of like getting there because waiting like 5 minutes for a single result is not pleasant for kind of user experience, especially for kind of the very iterative process that the creative process is.
Right. This the speaker again. The session is over. Now we're going to have the next speaker. We have to use panel discussion. One by the speakers to the front. When you can see it or you can stand, by the way, you feel more comfortable. That's the way of sharing your. Yep.
Next slide.
Quick introduction, maybe again.
Yeah.
Just very brief introduction of them again for the new people.
And for those of you who come late, maybe I can briefly introduce our speaker again. So here we have Aaron from Adobe, and we have Anna Stanford from Runway, and also we have Jiabing from the University of Maryland, College Park. So now let's break the ice. Personally, I'm also very curious. So considering your diverse experience with generative AI and computer vision, have you engaged in creating art yourself, maybe as a kid or now? So this could include traditional forms like painting, sculpture, or digital creation that you might not strictly use the methods that you develop professionally. So could you share some examples if there's any? Thank you.
I double majored art in computer science in college, so I used to do a lot of painting and I picked it up again, and so that's kind of the main thing I enjoy is just painting and drawing. And I feel like a lot of my academic research has been informed by things that I've learned through the drawing system. Like I mentioned in the Q&A before, I experimented with text image stuff for making stuff for a while. It was fun for a little while, but I enjoyed more direct, just the pen and the tablet, basically.
Yeah, so Runway started in art school. So for Runway, these days I don't have much time to make art, but before Runway, I was making media art, I was making also graphic performance art. So a lot of kind of the inspiration and stuff of running is just building tools for that. Just realize how difficult stuff. Incorporate those systems without spending most of the time. So get set up.
By the way, is it on? Like, can you hear in the back with that mic?
You're just getting closer to find it.
Oh, maybe? Okay, cool. So I'm up the examples. I don't like, I'm terrible at drawing and terrible at paintings and, but fortunately, the computer vision techniques can allow me to create things that I otherwise could not. So kind of one of the examples I now can do is that a couple of years ago, we have this work that take sketches and then you can create 3D sculptures that you you create multi-view interpretation of the same sculpture. And we have that in the exhibit in a university. So like if I would, I mean, I don't have the artistic skills and time to work on those projects, but with computer vision and this graphics, that provides a tool for me to express myself as well.
Thank you. Thank you all for the brief overview about like art related kind of like skills. And I think now moving forward into another question, like maybe touching on Aaron's point about like how technology helps basically develop new art forms. Have you experienced or have you noticed how generative AI basically is helping develop new ways of art form? Like, or is there any kind of like concrete example that you have seen? Oh, I may consider like this new kind of like genre or this new trend coming out from generative AI technologies. Like, have you experienced anything so far? Anything you can comment?
For me, I feel like the latest diffusion-based stuff, I haven't responded to a lot. Like, I see cool stuff people are doing. It's all like, oh, that's a neat thing, and then I forget about it, 10 seconds later. It's very cool and exciting and stimulating. I think a lot of the sort of previous wave of neural AI art, like 2015 to 2020, based on GANs and related technologies, those stuff I really liked. I like Blaine Sarin, Martin Kligelman, Sophia Crespo, and like some of that stuff probably in the AI art talent here. Like that felt like people were iterating, building their own, writing their own code, building their own training data sets, building with the models, and really exploring things and making cool stuff that I think is more memorable. And then I feel like the new diffusion stuff, to me, I haven't really responded to it as much.
Yeah, I'll echo that. Like, so basically, I think the main thing is that if you see an art, like I think that because the digital model take away a lot of things, you just have a text and like random people can have just similar text, just create the images. So it doesn't have a lot of like kind of human creators involvement. So you really the things that's interesting is usually come from the process, iterative process. So that's probably why the kind of we don't see a lot of like interesting like something like deeply personal. How do you kind of create something that's resonate with people? Yeah.
Yeah, so I think I disagree about the idea that there's not as something art personal making models. I did really like that kind of real aesthetic era as well, and experimentations of the actual techniques and just really getting a deep understanding of kind of how the networks work. So I was a big fan of kind of that era. But I think what's different in this era is like people that are not necessarily technical are able to now tell stories with very limited resources that they will otherwise solve. Like we've done 2 years of our AI film festival, and we've had folks that some of them came from traditional film background, a lot of them really like that was indeed the first break or the first movie that they ever made, and we saw some really personal films we made at the festival. One of them came from the University of Childhood, and it was a very simple concept. The artist behind it just took something with somebody's childhood and just use any much you can involve. But it's fun and very much strange way. And that despite the simplicity that was the result was really very
Yeah, thank you for those point of views. I think there's something that I see, a common word that I saw in the 3 presentations we had today was iteration. Like, and now even like in this discussion, you mentioned iterative, right? But it sounds like if we're iterating with generative AI or whatever form of AI we're considering, this AI needs to know our intention, right? Like, because if not, it may derail, right? Like, how can you iterate if you have a machine that is not aligned with you? How can you actually make the machine to be aligned with you and actually help you through this iterative process?
I don't know that it has to know your intention, because that's really a lot to ask. You know, a typewriter or paintbrush doesn't know your intention when you're painting with it, but it's predictable enough that you can control it to do the thing you want, which is not the same, you know, maybe it knows my intention when I move the brush to the left, and it should paint to the left, but it's more about controllability and predictability. And you don't necessarily want perfect predictability, because you want to, like, if you're more exploratory, you may want to discover things or have things happen by serendipity, like with watercolor. Things happen with the change that you didn't intend. So I think it's more about providing the level of maybe predictability that you want, and the serendipity being more controllable or only happening in ways that you expect. That's not the answer. The question, maybe.
I do think there's a lot of limitations in terms of how controllable the models are. We're trying as runway to make a progress on. I think something unfortunate that happened in the past years has been that fidelity improves faster than controllability, and just getting these models to produce pretty pictures was like the whole era. I think those models even need to be quite correspond to your prompt. But I think that as soon as going to change, then controllability and fidelity capture your intention will improve. And one kind of thing that we pay attention for Generative Alpha is that likes to have a more naturalistic outputs or different style outputs, not necessarily have this kind of generative aesthetic, and kind of move away from that. The final thing I guess I want to point out is that, like, usually your intention is very blurry and hazy as you're creating art. Like, it's not like you always have like a super clear idea of what you want to create. It's more like discovering the tool. So I think it's something that are so I think another aspect, and I think very important as we're building those tools, is really surfacing interesting directions for as you're creating, so that you're
Yes, so I think you want to, one thing that I think that I personally have the kind of obstacle is that a lot of this control tools, they're kind of heterogeneous. Like, basically, sometimes you want to have like conceptual control, sometimes you want to have like a more precise spatial control, and sometimes you want a specific color and so on. So it's, right now it still doesn't have. I haven't seen any kind of tools that allow you to integrate them nicely so that you can really explore the space of the imagery you want to create. So I think that's kind of probably what the next frontier will look like. I think kind of explore all this kind of controversity that you human can fully express themselves. And also I want to echo that a lot of time, like when you try to create, when we kind of create these slides and all this kind of visual documents, you usually don't have a perfect blueprint in your head. Like, you want to kind of, when you just go along, and then like the idea will get clear when you work on it. So I think that the exploration tool need to also have that kind of capability, kind of help show you different options. And that kind of, I think that way, the tool is not just purely a tool, but also kind of, you can think about a system to help you kind of be more creative.
Yeah, thanks for the speakers. I organized an AI for filmmaking hackathon in some February, and I noticed there are many various kind of workflows. Some people will shoot real life footages, and then they will use style transfer to make them more artistic. And some people will first generate images with text to image models, and then expand them into a film clip. So I want to ask all the speakers here, have you seen any kind of integration of AI technology into the artistic workflow that you think is quite creative or helpful? And maybe you can each provide some examples of some interesting workflows you have seen these days.
for the things people don't even control that, combining control that with like 3D, for example, pretty interesting. But that's all I got.
Okay. Just close it.
I mean, maybe one specific question for like, I mean, you're working closely with filmmakers, I guess. So have you seen, I mean, what's their perception of these tools basically, and how do they, like, have you seen anything creative from the filmmaking community? Like you say, oh, we didn't expect them using the tools in this way. Is that something have you seen so far from way?
Yeah, so I mean, yeah, a lot of filmmakers are using Runway. I think what's most surprising about kind of how people are using AI tools this way is like how everyone has their kind of very specific, unique workflow around how they use those tools and how they're combining them with different. So kind of one example to Aaron's point is like we've seen with our Gen 1 tool, but it's beautiful. Generally, it's a less popular tool than video because it requires more investment from a user perspective. But we've seen that to be used in all kinds of interesting ways. You can, for example, render a scene using kind of video to video, but just taking a manufactured kind of 3D scene and then passing it through Gen 1. You can take NF kind of walkthrough and pass it to Gen 1 to get a stylized version of it. So we found Gen 1 very very composable with kind of other workflows.
Yeah, I just want to recommend like on Twitter I follow a artist it's called Karen Zhang. So like I think she experiment a lot of like these kind of generative models in a very creative way. Everyone should follow her.
Great. Yeah, so maybe derailing a little bit the conversation here into more kind of like just thinking, I mean, looking forward, like we have been working like in separate communities, like for instance, there's the vision community who has been focusing on developing the generative models. Maybe now there's a relationship between vision and graphics, but do you think we should have more like cross disciplinary basically meetings where we discuss about generative AI and art and things like that? For instance, can we involve also psychologists, HCI, the HCI community into the developments of the tools and the experiences we build? Because we have been talking about, first of all, iteration, right? We need to have iterative tools. Second thing that came out from last discussion was controllability. So it seems natural that we want to have a human in the loop. Like when I create art with a human, and so that means we need to integrate multiple communities like HCI community, potentially psychology and perception. So any thoughts on this frontier and what can we do as an academic community to encourage these cross-disciplinary like meetings on conversations basically as well?
Yeah, I'm a big believer.
Yes.
I'm a big believer in these interdisciplinary connections, and I think we've already benefited so much from the interaction between graphics and vision. Like I see there's so much going on here that 10 years ago you would see the graphics conference and not using vision. Historically, I think vision people want to solve the AI problem and make artists obsolete, and graphics people don't believe in automating these things. And now I think there's a lot more overlap. I think it's like HCI are much more focused on creative tools, and they have better creative workflows and better practices for involving humans and users early in the process. I think a lot of the work that we do in graphics and vision is like, okay, I have an idea, I'll build a system, and then at the very end, I'll have some crowd workers click on it, and then I'll get better scores. Whereas the HCI practices are much more like, okay, what do people actually want? What happens when we like do exploratory study to see what people are interested in, where they're working, and try to connect our research goals with what people actually need. And so that's one way that I think these areas can benefit from HCI. I think all these others, this may feel a little left field, but I think philosophy is one field where I've been finding lots of really valuable connections between that and perception. And like the Platonic representation hypothesis is one that the philosophers are talking about a lot and have a lot to say about. And when we get into discussions about the nature of art, nature of creativity, I think the philosophers can benefit a lot, and vice versa, they can benefit from our work. So small meetings, symposium, workshops are one way, I think, to perform these connections between like-minded people with compatible interests, and that stuff I find super interesting.
Yes, I'm here. So I think one of the good model I can think about is that when I attend the graphics conference, like SIGGRAPH, they have a lot of tracks about not just about like the technical paper section is very kind of I don't know how many percent is probably 10% of the conference. But a lot of them are talking about like industry filmmaking process and art show and the kind of various different kind of tracks, and that they talk about different stages, and there are a lot of like there you will be able to meet a lot of like artists and then kind of people who actually use the tool. But here like I think like, probably a few years ago at CBPR, basically everyone is talking just about the tool, but nobody really talked with the users. So I think this workshop, and then I think going forward, and recently I think the CBPR also has this art like demo. I think it's also very good. So I think we're moving toward that direction where we have a multiple dimension, multiple aspects discussions.
I'm fully supportive, more in terms of cross-disciplinary interactions happening. I think artists working closely with really informs I think it's also like one fascinating thing to me about kind of a lot of research in learning is like I said preference in running user studies to determine because that's models. And I think it's that often that students is going to be personality of like what's more preferable. I said Excel, and for us, we've never been able to fully rely like on the competition of those models. Nothing. Having those discussions generally with the artists, and I'm really understanding like so creative models.
Okay, thanks. I think like we're on time, but we can let the audience ask one question. Like I think you were with your hand up for a long time. Yeah.
So my question about is, so in art, you have these abstract representations of objects, say, drawing, like two hearts in the sky in the bird. I wanted to know how the current models is able to, or how it's handling this aspect of abstraction in art.
I guess it depends what you mean by handle abstraction. I think, you know, as I think as I mentioned, you know, if we've seen, you know, they're all taking data. So if they've seen these abstractions before, then they can learn them. And if they've seen outline drawings for things that they've seen lots of physical, you know, shaded drawings of, then it ought to be able to abstract the notion that the outline can represent the contour of an object rather than just being a physically valid representation of it. And they could abstract from that maybe you don't need to draw all the time. So like anything you see enough patterns of, you could in principle have models generalize because there's subroutines that we put for.
Yeah, I think on a similar note, there's definitely like the models are able to generate Excel, like a different like level of detail and abstraction. I think it really kind of depends on how abstract do you want to get. Like I think they probably the models will try to have to produce an output that's the same where most people would agree like something specific to depicted, and if it's something that's kind of so abstract that it's only kind of kind of specific for you, then I think that's also an opportunity where, creating a custom model for really kind of identifying ways to personalize them for controllable further would like you basically provide the abstraction component that
I guess the kind of one aspect that is, I think different because the model has seen several different abstractions. I think that's one thing that's fascinating me. I found it fascinating is that how well those models can really generate different concepts. Like so, and never definitely there's no data that's astronaut riding horse or the horse riding an astronaut, but these models are able to kind of synthesize those kind of abstractions. So it seems that it's very data efficient in a way. Like these type of generative models are able to kind of filling out the gaps of visual space, the compositional space. So I think it's very fascinating.
Yeah, thanks all the speakers for your amazing presentations and also this wonderful kind of discussion. Let's give them another round of applause. So our next session will start at 10:20. So stay tuned. And also, I would like to make an advertisement myself. So we are organizing the MIT AI for Filmmaking Hackathon, and here you have the unique opportunity. If any of you want to show off your models, we can pair you with a team of artists. So, hey, do you know who will chair the next session? Who will chair the next session?
Alexander.
Where's
Yeah. No, everything is different. Yeah.
We're calling later. Oh, I don't think I'm still
Do you have an adapter for this USB-C? Do you have an adapter, a USB-C